Conventional welding processes are limited in the fact that while they do have the ability to make good welds, the process window that they offer the good results in can sometimes be limiting. Variations like tip-to-work distance or variation in torch angle can sometimes determine the success or failure of the process. The first demonstration is the ability of the active wire feed process to handle a sudden increase in the tip-to-work distance. The side-by-side comparison using high-speed video shows how quickly and controlled the sudden transition can be handled and the extremely low spatter expulsion as a result. The active wire feed process widens the arc welding process window due to the synchronization of the feed system, robot motion, and the welder output control. This new process allows the user the ability to handle more variations than a conventional process would allow. The slide to the right also shows the versatility of the welding process in another key area, torch angle compromise. In conventional welding processes, when the torch angle, drag or push, exceeds a desirable amount, typically plus minus 10 degrees, the spatter level and welding process run out of control. As you can see from the spatter generation chart, the active wire feed process has excellent spatter generation performance since it is not affected by arc reaction forces.